more problem from quadratic equation, that is x square plus bx plus c equal to 0 and x square plus cx plus b is equal to 0. Have a common root. Then show that b plus c plus 1 equal to 0. We have the problem from quadratic equation x square plus bx plus c equal to 0, x square plus cx plus b equal to 0. Have common root. We have to prove b plus c plus 1 equal to 0 condition. So you see here we have equations x square plus bx plus c equal to 0 and x square plus cx plus b equal to 0. This is equation 1 and this is equation 2. Equation 1 and 2 have common roots. So here 1 minus 2, that is 1 minus 2 x square plus bx plus c minus x square plus cx plus b equal to 0. Then here x square can cancel, bx, that is b minus c of x plus c minus b equal to 0. Then b minus c of x, you take minus common, minus of b minus c equal to 0. Then what we will have? B minus c, x is equal to b minus c, x is equal to b minus c by b minus c is equal to 1. What is the root of this equation? 1. X is equal to 1 is the one root, and you have to substitute x is equal to 1 in equation 1. In equation 1, then 1 square plus b into 1 plus c equal to 0. Therefore, b plus c plus 1 equal to 0. We have the required condition. Hence proved. Okay, all of you? That's all. Thank you, all of you. We have one more problem from quadratic equation. If the quadratic equations ax square plus 2bx plus c equal to 0 and ax square plus 2cx plus b equal to 0, where b not equal to c, have common root. Then show that a plus 4b plus 4c equal to 0. We have given two quadratic equation. That quadratic equation have common root. Then we have to prove this condition, a plus 4b plus 4c equal to 0. So you see, given quadratic equations, that is ax square plus 2bx plus c equal to 0 and ax square plus 2cx plus b equal to 0. This is equation 1 and this is equation 2. Let alpha be common root. Then a alpha square plus 2b alpha plus c equal to 0. A alpha square plus 2c alpha plus b equal to 0. Then subtract these two. This one cancel. Alpha of 2 alpha of b minus c. This is plus c minus b equal to 0. Then you have to take common minus here. 2 alpha of b minus c minus of b minus c equal to 0. 2 alpha of b minus c is equal to b minus c. Then we have alpha is equal to b minus c of 2 of b minus c. b minus c cancel. Alpha is equal to 1 by 2. So what is the alpha? Common root is equal to what? 1 by 2. Alpha is equal to 1 by 2. You substitute in equation 1 or equation 2 as you like. Here we substitute alpha is equal to 1 by 2 in equation 1. That is, substitute alpha is equal to 1 by 2 in equation 1. Then what is the changes? A into 1 by 2 whole square plus 2b into 1 by 2 plus c equal to 0. Here 2 cancel. A by 4 plus b plus c equal to 0. Then you take LCM 4 LCM, then a plus 4b plus 4c equal to 0. Therefore, condition is a plus 4b plus 4c equal to 0. Hence proved. Hence proved. Okay, all of you. This is the condition proved. Okay, all of you. That's all. Thank you. We have one more problem from quadratic equations. The problem is, suppose that the quadratic equations ax square plus bx plus c equal to 0 and bx square plus cx plus a equal to 0 have a common root. Then show that a cube plus b cube plus c cube is equal to 3abc. We have two quadratic equations are given and the condition is two quadratic equation have common root. Then we have to show that a cube plus b cube plus c cube is equal to 3abc. So how to solve? You see here given quadratic equations, that is ax square plus bx plus c equal to 0 and bx square plus cx plus a equal to 0. This is equation 1 and this is equation 2. Okay, all of you. Equation 1 and 2 have common root alpha. Then equation 1, a alpha square plus b alpha plus c equal to 0. B alpha square equation 2 plus c alpha plus c a equal to 0. You can solve these two equations for alpha square alpha. So here you see alpha square alpha 1, alpha square alpha. Then what is the coefficient of alpha square? A, alpha b and constant c and a b. Here b c, a b c. Then alpha square by ab minus c square. AB minus c square is equal to alpha by bc minus a square is equal to 1 by ac minus b square. Okay, all of you. By comparing these two, alpha square is equal to ab minus c square by ac minus b square. By comparing these two, alpha is equal to, this is bc minus a square by ac minus b square. Okay, all of you. Then after, you see, here you see all of you, alpha square is equal to alpha square. So from this one, alpha square is equal to alpha whole square. What is alpha square? AB minus c square. AB minus c square by AC minus b square is equal to, what is alpha? BC minus a square. BC minus a square by AC minus b square. This is whole square. Alpha whole square. AC minus b square, 1 AC minus b square, then cross multiplication. AC minus AB minus c square into AC minus b square equal to, this is in the form of a minus b whole square. B square c square plus a power 4 minus 2a square bc. So multiplication of these two, a square bc, and this is ab cube, and these two minus ac cube. This is plus b square c square equal to b square c square plus a power 4 minus 2a square bc. bc b square c square, b square c square, both sides are cancellation. Then you take this into this side, these two into this side. So what is the changes? This is, you see all of you here, a square bc plus a square bc plus 2a square bc equal to, here a power 4 is there, plus ab cube, plus ac cube, This is 3a square bc equal to a common, a cube plus b cube plus c cube. Here 1a, both sides cancel. Therefore, what we can written as a cube plus b cube plus c cube is equal to 3abc. Hence proved. Okay, all of you. This is a cube plus b cube plus c cube is equal to 3abc. That's all. Dear viewers, we have one more problem from quadratic equations. That is, if x square plus 4x plus 3 equal to 0 and 2x square plus 3ax minus 9 equal to 0 have common root, then find the value of a and the common root is. Here we have given two quadratic equations, and condition is the two quadratic equation have common root, and in that quadratic equation if variable is there, we have to find the value of a, and also we have to find the common root of two equations. Okay, all of you. Then you see here what equations are given. So given quadratic equations are, that is x square plus 4ax plus 3 equal to 0, equation 1, and 2x square plus 3ax minus 9 equal to 0, equation 2. Let alpha be common root. Alpha be common root. Then what is the quadratic equation? Alpha square plus 4a alpha plus 3 equal to 0, and 2 alpha square plus 3a alpha minus 9 equal to 0. Solve for alpha square alpha. That is alpha square alpha 1. Alpha square 1. This is 1, 4a, 3, 1, 4a. Here 2, 3a minus 9, 2, 3a. Okay, all of you. Then what we will have, you see here alpha square by 4a into minus a, minus 36a, minus 36a minus 9a, minus 9a equal to alpha by this is 3 to the 6 plus 9, 6 plus 9 is equal to 1 by 3a minus 8a. This is 3a minus 8a. So alpha square by minus 36 minus 9, minus 36 minus 9 minus 45a equal to alpha by 6 plus 9, 15 equal to 1 by minus 5a. Here you observe 5 1 ja, 5 3 ja, 5 9 ja. Okay, so this is alpha square by minus 9a equal to alpha by 3 equal to 1 by minus a. What is alpha square? Alpha square is equal to, this is minus 9a by minus a. Minus minus plus a cancel. Alpha square is equal to 9. Alpha is equal to 3. Okay, all of you. Then what is alpha? By equating these two, alpha is equal to minus 3 by a. But what is a? A is equal to 3. That is minus 3 by 3. This is equal to minus 1. So here, sorry, here, this one, here, what is alpha? 3. 3 is equal to minus 3 by a. Okay, so 3 cancel. A is equal to minus 1. What is the value of a? Minus 1. Value of a minus 1. And what is the common root? Common root alpha is 3. Common root alpha is 3. 3 is the common root alpha, and here a value is minus 1. Okay, all of you. That's all. Thank you. Here we have the one more problem from quadratic equation. What is that? Here, prove that the roots of x minus a, x minus b is equal to h square are always real. So, here we have given quadratic equation is, that is x minus a into x minus b is equal to h square. So this can be written as x square minus x of a plus b plus ab is equal to h square. This is x square minus x of a plus b plus ab minus h square equal to 0. So you compare this way, ax square plus bx plus c equal to 0. Delta is equal to ab minus h square is greater than 0. Roots real, that is b square minus 4ac greater than 0, and b square minus 4ac less than 0. Roots imaginary, and b square minus 4ac equal to 0. Roots equal. From this condition, you can verify this condition. So what is delta? Delta is equal to, here what is, a is equal to 1 and b is equal to a plus b minus of c is equal to ab minus h square. Substitute here b square minus 4ac, that is minus of a plus b whole square minus 4 into a, 1 into c, ab minus h square. So delta is equal to a plus b whole square minus 4ab plus 4h square, 4h square. So a plus b whole square minus 4ab is what? Delta is equal to, this is a minus b whole square. A plus b whole square minus 4ab is a minus b whole square plus 4h square. Delta is equal to a minus b whole square plus 2h whole square. This is always greater than 0. This is always greater than 0. Then we say delta greater than 0, then roots are real. Roots are real numbers. Okay, all of you? That's all. Roots are always real numbers.